1241, May 11, 2026, right now marks 2,351 hours of progress on the global horror simulation. Finally, the simulation of human cone of vision with voxels is finally working with perfect raycasting level accuracy without traditional raycasting, as well as being able to run on tens of thousands of voxels simultaneously. And so basically, as an indicator of the performance, there are currently 64,000 voxels being processed, and it is able to block them all no matter where the blockage is occurring. It blocks them accurately with perfect accuracy, and it can also block the minimum amount of voxels necessary. And so basically, the way this works as a demonstration is that every voxel has a unique ray towards the eye point, and in order to show that better, it'd be necessary to decrease the volume of the grid, as the algorithm itself is so fast that the tools that are being used to draw it, which are basically some of the engine's gizmos, and for whatever reason the gizmos draw on the CPU, and the actual code itself for detecting the line of sight is also CPU based. And the way this was made to work is that every single voxel has a unique path towards the vantage point, and then that path is then divided into nodes, and each node, so instead of a ray doing a sort of double-nested check of each point along the ray, basically every ray is made up of nodes, and nodes check the previous point on the node as the parent. And so it begins at the vantage point and sort of goes outwards, and if this point is blocked, then of course the next child, which would be the next node in the ray, would determine itself to be blocked, and so that sort of goes outward perfectly and is able to do so with insane speed. So it works perfectly, it would seem. So that's raycasting levels of accuracy without traditional raycast. So this isn't using any sort of physics, but just an object in the world converts its position to a spatial hash, and then that sort of communicates with the grid and determines that cell to be blocked. And cells that are blocked by geometry aren't hidden, but the cells that are behind them are hidden along the path to the eye. And so it seems to be working phenomenally well. And just as an indicator of the performance of this in terms of frames, using around 100,000 voxels, although the editor doesn't run quite as fast as it could because it's still trying to draw them all on the CPU, the actual performance here basically has no impact on the performance, as the frame rate does appear to be decent, but even better indicator is the time in milliseconds, which under 4 milliseconds seems to be quite okay for that. And so even changing that to be VSync, it does appear to be hitting that frame target of around 16 milliseconds. So the intention going forward, now that that appears to be quite well optimized, and as another example, with around 64,000 voxels calculating line of sight for them around every single millisecond, and it calculates it accurately and precisely and quickly. And so the intention going forward is to now try and combine this system with the other systems in order to create 3D fog of war, which disproves that it would actually be possible to create fully three-dimensional fog of war that can accurately adapt to height of a level's geometry. Although one thing that could be improved is merging nodes, as currently every ray has a unique set of nodes towards the vantage point, but nodes could be merged, and although one would think that you would merge nodes that occupy the same voxels, the actual other iterations of this have proven that what needs to be done is to only merge nodes that are occupying the same voxel and have the same parent. So they go in the same direction. So as two rays can pass through the same voxel but not have the same exact path. So one could be going from down there and going through a voxel, and one could be going from the side. And so the intention going forward is to look into merging them in order to reduce the number of nodes, which would seemingly require using classes instead of structs, as classes can allow for unique IDs for every single node, whereas using structs and value types, each node would just be a value, and so updating the node in one array would not update it in other arrays, whereas with classes, updating a reference to a class in one place updates the same everywhere else. And so the intention going forward is to finally look into implementing this or integrating it with some volumetric fog in order to see how that works out, as currently seems to be working pretty well. Tens of thousands of voxels per second with perfect line of sight, which, as a comparison, trying to do raycast to 64,000 voxels normally would not be very good for performance, although in an empty scene it wouldn't be so bad, but as a scene has more and more geometry, that would sort of tank. And so this implementation is far more scalable and robust. And so the intention going forward is to make the most robust fog of war system possible, using this new method, which is basically voxel casting, raycast for voxels without actual physics, in order to make it run as fast as possible.